Imagine that you are a small farmer in Indiana, about to plant your crop. You would like to maximize your crop yield, but the coming year could result in a bad harvest, or it could be massively successful. Ultimately, you do not know. What if we were to tell you that we could predict the yield of your soy or corn crop by relating the coming year to similar previous years?
Yields can vary greatly from year to year, and even location to location, due to factors which can broadly be classified into weather/climate, environmental, and farm management factors, which is a lot to account for. In addition to that, technology improvements tend to present yearly yield increases, but including this trend naively in our data makes it very easy to miss large drought years, such as 2012, as the trend drowns out other factors, like the white noise of an airplane drowning out other sounds you hear while on board. Because of this, for each county in Indiana, Illinois, and Iowa, we calculated the trend increase in yield using linear regression and removed it to obtain the detrended yield for each county, so that our model captures the yield's relationship to the climate factors that ultimately govern the yield our farmers can expect.
With the detrending completed, we then obtained and processed climate information, including temperature, precipitation, and solar radiation, from open source datasets furnished by the US Department of Agriculture and NASA, and fed it into our model along with detrended yield to classify analog years, which are years that are simply like previous years. Consulting prior research, we concluded that a model sporting increased accuracy, since it's composed of a consortium of other models, called random forest, would be a great method to classify analog years. This is how our model works in simple terms. Yields are classified into one of 6 levels, from level 0 to level 5, which indicates the amount of yield a farmer could expect for corn or soybean. For example, the corn yield in the coming year in Adams County, Indiana could be level 5, which means that farmers can expect roughly 10% more yield than what they would have achieved simply due to the trend progression in yield mentioned earlier.
The model we created merely makes errors within one level on the level 0 to 5 system, which amounts to around 10% errors in yields, which is what the figure known as the confusion matrix highlights if you look at the diagonal. Now, instead of worrying about whether or not the soybean or corn yield at the end of the year will be enough to make them a profit and feed their families, farmers across the length and breadth of Indiana, Iowa, and Illinois will be armed with more information that will help them manage their crop in a more efficient way and reduce uncertainty. The biggest job on earth, carried out by thousands of small farmers across the Midwest, will now yield bigger and more precise results, thanks to the collaboration between the Purdue Data Mine and BASF.